So, good afternoon, everyone. I'm Panumart Booncharoensombut. Today I'm going to talk about the calibration and validation of building simulation models of overheating risk predictions. Before getting started, let me provide you with some background information. As you can see from the graph over there, it is a projected of increased temperature due to global warming, driven by the emissions of greenhouse gases. And this is not only affect to outdoor temperatures, but also influence indoor temperature as well. And as you can see from this graph, the heat-related dates in the UK, if we have no adaptation, it will be significantly increased by 2050. So therefore, the aim of this study is to improve the accuracy of building models in predicting the overheating risk by employing a validation and calibration approach in the case study house, as the building simulation models are usually used to evaluate the passive design strategies. And the study drives to three objectives. The first one is evaluate the accuracy of building simulation model in predicting overheating risk. The second one is identify the influential model inputs and the relationship with indoor temperature. And the last one is employ a Bayesian calibration to fine-tuning input parameters to achieve the most accurate result. This study was focused on Bayesian calibration, as the Bayesian calibration has been used, widely used to fine-tune the parameters, but it was focusing on mainly in energy consumption. So this study would address this gap to use it for overheating risk. Then this is the methodology that used in this study. It was structured into 6 steps. Let's start with the first one, the model development. The case study in this study is a semi-detached house, which the secondary data was used from an open data access. The house on the left-hand side, the west house is unoccupied, and the east house on the right-hand side is synthetically occupied. The synthetically occupied means that the internal heat gains and schedule in the house was set following the measured values obtained from the plot meters. So in this one, the east house, the internal heat gains was set following TM59. And the data that's set to the models was used from the plot meters, which is quantified from the actual power that the light bulbs were generated. And in this table are the schedule between unoccupied and occupied house. Then let's move on to the next one. After I developed the model, the overheating risk assessment was developed using 60TM59. So both criteria would be met for homes that naturally ventilated. And then after that, the sensitivity analysis was done. In this study, I used from Roberts et al. Study because they'd done on identifying discrepancy in the same test house. So I developed further from that one. And then the IMSC results from that study was used to evaluate relative changes. The parameter that showing the significant changes of the IMSE were considered influential and then was used in the calibration approach. And then after it came up from the parameter, the scatter plots and correlation metrics were used to identify the patterns and trends of these variables to be able to group the variables for the alternative calibration iterations. Then comes to the calibration approach. As a novelty approach for these studies, this study incorporates the uncertainty into measure data variables. With the calibration process was done by 4 parallel chains with 500 iterations, resulting in 2,000 iterations in total. And then the Gaussian process was developed in this study for the meta model to reduce the computational time. And the study was focusing on just a week of the hottest period of July in 2021. So as you can see from the table, the trending input parameters are measured data from 16 to 19 July for the first 4 days. And then after that, the calibration process was done in the latest 4 days, with the output is the predict mean operative temperature. And then these are the 15 iterations that has done with the group of alternative vector variables. And then after running the calibration, the I-hat was used to assess the chains to be able to make sure that it fall into the acceptable range. And then after that, the validation approach was done using the metrics to quantify the differences between uncalibrated and the calibrated models. Then comes to the results. As you can see from the graph, the overheating risk results shows that there are discrepancies between monitor data and simulated data, especially in the criteria B that from the measure data, it accessed the limit, but in the simulation models, it couldn't capture any risk. And then the sensitivity analysis, it shows that from the results of this graph, the weather variables have the most influence on the building model's performance results. So it has been used in this study. Then after that, the exploratory analysis shows that there are relationship between these variables with the operative temperature. So I used it for the calibration process. And then these are the results from the calibration results. You can see that from the validation metrics, it has reduction like up to 50%. And if you can see from the overall graph that I compare from the uncalibrated and calibrated models, it can be seen that the calibrated show I'm closely aligned to the measure data. And to conclude, the simulated results fail to show overheating risk, and weather data has a crucial parameter influencing the accuracy. And as a novelty of this study, including uncertainties into weather variables could make it reduce in errors. And that's all my presentation. Thank you.
Thank you very much. Is there any question from the audience? Then I need to ask you a question. I was wondering, this is a very thorough study, but you've identified a couple of differences, obviously, between your simulated model and your real data. How confident are you that your calibrated model can be reproduced for other case studies of a similar nature? Because that's the interest of trying to not just do the theoretical analysis on one particular case, but to allow some sort of extrapolation for future use. Thank you.
Thank you for the question. So actually, from the novelty approach from this study, we found that including uncertainties into weather variables could achieve most accurate results. So, but there are some limitations in this study, as you can see from the graph, that the calibrated one couldn't capture the pattern of the indoor temperature, comparing to the uncalibrated. So this could be because we just focus on 8 days in 2021 in the hottest week. So to extend that period could capture more, and including the lack of temperature components would be able to capture more patterns. And as I mentioned here, that to encompass geographically diverse climate condition would be able to understand, because it depends on weather data. So it would be different in other locations and other houses as well.
Thank you very much.
Thank you.